Alright, so in this second part of the video, especially with object-oriented programming, we are going to look at this one. We are saying that you should write a constructor method in the rectangle class. So the instructions are very descriptive, and assign the following attributes: length and width. So remember earlier on I also said, well, with the objects we can combine attributes or data, and that's exactly what we want to have over here. So let's look at the bigger picture. Now we know that for every rectangle we are going to have length and width. Those are the data attributes we can think of about in a rectangle. Okay, in other instances, if it is a car that we want to model, we can look at maybe the color of the car, and these are data attributes about the car. Okay, we can look at maybe the engine transmission type. We can look at whether it is a diesel or a fuel or a gas or an electric vehicle. We can look at the number of seats, a lot of other attributes we can think about. All right, now in the case of rectangle, we can only think about length and width. Now we are saying that we are creating a constructor method. Okay, so that is very instructive over here, a constructor method. So this is a method, but then we are calling it a constructor because this is a special kind of method. And this method is I see this all the time, it is more or less the soul and spirit of the class. Okay, so let's assign the attribute first and see how things goes. So over here, look at this. We are going to come, still in the class, okay, inside of this class, and I'm going to assign the attributes. Let me have a float for the length, okay, and then let me have a float for the width. So these are basically variables we have declared, and we are saying that we need to create a constructor method. We already know what these methods are. They are basically functions, but then the constructor method is a little bit different. Okay, it's very special. It's very special in the sense that, look, whenever we create for instance a plot of land, it is not just for the fun of it, because this plot of land is a creation out of this rectangle class. Now the big question is, okay, what is a plot of land without data, without attributes, without the length and the width? So definitely there's some values or some data that needs to be presented, and that's the reason why we need the constructor method. So the constructor method is practically like any other function or any other method we write. However, this one is different. In order for C++ to know that, okay, well, this is your constructor method, the name of the method should be same as the name of the class. So I'll say rectangle over here, and over here it does not have a return type. Okay, so now when I do this, C++ knows that, okay, well, this is a constructor. Now the constructor method is automatically invoked whenever an object is created, because that's what is going to set these attributes for the length and the width. So now the moment I create this plot of land, I expect to have, let's say, a 20 for the length and a 10 for the width. And the question is, okay, where is this going, these values? Because these are parameters, or sorry, these are arguments we are sending into some parameters, and those parameters are going to be contained in the constructor method. So now look at this. I'm going to say float, and I'm going to say L, and then float, and I'm going to say W for length and width. So now the big question is, okay, as soon as this plot is created, the constructor method is executed, and it is expecting a length and a width value, which I've provided as 20 and 10 respectively. So when those values are sent here, then what I need to do is, okay, I need to grab this original length as I have over here and assign it to this L. Remember, this L will be this 20 value that will be sent, and then finally the width will be this W value, which in this case is 10, which will be sent, because the constructor method is automatically invoked when an object is created. So now with this, what I can do is, okay, so I've created something over here. Now when I run this, there is an issue over here, and it's saying that, just as we saw earlier on, that this rectangle, float, whatever is private within this context. So if it is private, then we cannot access it. So in the notes, we are going to see there's access modifiers. Okay, now earlier on we have made this public, that's why it is only salute function that we can see. So what I'm going to do is I'm going to take this public and I'm going to put it at the very top over here. So now what is going to happen is, because this public has been brought up here, it is going to make this length and width public. It is going to make the constructor method public, and it's also going to make this void salute function method also public over here. So now when I run this, because now everything is public, I don't have any problem. Okay, all that we have done over here is we have just created the plot1, which is a creation out of this rectangle class, and then we have provided these values to it. Okay, so now if I'm to come in here and if I just want to do a cout, if I do plot1 and I do a dot, remember the dot operator, I want to go into it. Now when I go into it and do dot length, the question is, okay, when I go into plot1 and I want to access this length, how do you call it, variable or attribute, what is this length? This length, as you can see over here, is equal to this L, and this L is coming from the constructor method. And this constructor L, because it is automatically invoked when this plot1 was created, we needed, or we provided a value of 20. So at the end of the day, we are going to see 20 over here. So now when I run this, we are seeing exactly 20 over here. Now the reason why we are doing this is because this is object oriented, so the programming logic, everything is going to revolve around the objects. So now that we have this, we have set those attributes, and we have actually completed the second part of the question. Very simple. Now we need to create an area method to calculate the area of a plot of land. Absolutely simple over here. We know the formula, okay, and the formula has been given to us. So the area is going to be equal to the length times the width. So over here, I come in here, and let's just get rid of this salute whatever thing over here. So in here, I'm going to say, okay, I'm expecting a float, okay, and I'm going to call this plot underscore area. Then this plot area, the question is, okay, now I can leave this blank over here. Okay, I don't expect to pass in any parameter because these attributes are going to be accessible. So because these attributes are going to be accessible, I can simply do let's say return, and then I'm going to do the length. Sorry, I'm going to do the length multiplied by the width. It's as simple as this. Once you do this, this is about maybe an extra 5 marks or so. Okay, you are done. Now in order to access the plot, the area, okay, I can simply do plot1 dot plot area, and because this is a method or this is a function, I need to invoke it this way. So when I invoke it this way and I run this we should expect a 200 because this is 20 times 10. Very simple. Now the perimeter, once again, very simple. That's also going to be the float, then the plot underscore perimeter. Okay, these are names we are using over here. And then how do we get this? Okay, so once again, the formula is over here, and the formula is in, okay, to get the perimeter of the rectangle, it is given by this formula. So 2 times the length plus the width. So how do we get this? Okay, so let me just quickly show you exactly how this formula came about, but then you don't need to prove this or know this. Okay, the exams is not going to ask you to prove anything. So the length is the longest side, so this is going to be the length, this is going to be the width, and this is also going to be another length and another width. And the perimeter is basically the sum of the length and the width, okay, around it. So the perimeter is actually going to be L plus, we are moving in this clockwise direction, so L plus W, okay, plus the L down here plus the W at the other end. So we have this formula or this mathematical expression, and because we are dealing with algebra, we can group like terms. Okay, so we can do L plus L, then plus W plus W. So we are grouping all the L together and then all the W together. And once again, since this is algebra, let me just show this. Since this is algebra, L plus L, we are getting 2L, plus W, we are getting 2W. And the common factor over here is 2. So I can factorize 2 out, and 2 is going to multiply L plus W. Okay, so that's what we have over here. And that's the formula we see over here, 2 multiplying L plus W. So that's also very simple over here. We have the name, and then we can simply do a return of 2 multiplying, then we have the length, plus the width. Okay, as simple as this. So now if I'm to come in here and, for instance, I want to check the plot of the area, or the perimeter of the plot. When I do this, we get this value over here, which is 60. Okay, so this plus this is going to be 30 times 2, so definitely 60. So everything is looking good. Now the last one we have over here is to create the diagonal length method. Okay, that calculates the length of the diagonal. So the length of the diagonal, let's also come back here. This is the diagonal. Okay, this is the diagonal, and to calculate this length, as we have it this way, we are going to take inspiration from Pythagoras. Okay, because when we have this cross section of the diagonal, then we have a right angle triangle. So let's say we call this x. Now this x is the length, okay, of the diagonal, which based on Pythagoras we call this a hypotenuse. Okay, so this is a right angle triangle, so we have the hypotenuse over here. So with the hypotenuse, Pythagoras is telling us that the hypotenuse, which we have labeled as x squared, is going to be equal to the length squared plus the width squared. So this simple algebra and mathematics. Now we want to find x and not x squared. So in order to find x, we have to have the square roots of both sides. Okay, and the square root will cancel the square. So now x is now going to be left with the expression we have over here, which is root L squared plus W squared. So when we come back to the formula, that's exactly what we have. The length is going to be the root of L squared plus the width squared. So when I come over here, it's very important. Now, one of the interesting things we find over here is it is saying that we need to import the SQRT method from the math library. Okay, now it is very important. Now when we're dealing with the arithmetic operations, okay, let me just get rid of that over here. When we're dealing with the arithmetic operations, we saw something like 2 plus 8. Okay, we saw, so this is basically addition, and that's what we see over here, 10. Then we did for instance subtraction, so this is going to give us a minus 6. Then we did division. Okay, and we're getting some interesting values and stuff over here. Remember, the reason why we are getting this, okay, is simply because of something we needed to do some things. Okay, I hope you remember. All right, and we also looked at the modulus and stuff like that. Now the interesting thing is when it comes to mathematics, okay, these arithmetic operators are kind of complementary in a sense that the opposite of addition is subtraction. Okay, the opposite of multiplication is division. The opposite of so these are the common ones. And now, however, the opposite of the square, okay, so the opposite of square, or let's say the opposite of square, okay, is going to be SQRT, or the square root. Now when we are squaring and we are doing square roots, it's a little bit tricky because there's no straightforward way of doing it in C++. So the way we go about it is we need to import a library. So I'll come in here and I'll say I want to include And what do I want to include? There's a math library. Okay, we call it the C math. So when I say include C math, now what I can do is, okay, so when I come in here and do, for instance, par, and now do 2,2, all that I'm trying to say is, okay, I want to have the power of 2 raised to the power 2. So this is like 2 squared. And obviously we get a 4 over here. Okay. Then what about, okay, if I want to do 2 raised to the power 3, it's as simple as this. I call the power method over there and then 2,3. So when I run this, we have 2 to the power 3, which is 8 over here. Now, if I come in here and I don't bring this C math library, but then I'm still trying to use the power function or method over here, we get a problem. It says this power is not declared in the scope. Okay, so clearly it's almost as if we want to use C out without bringing IOStream. It is not going to work. We need the input and output stream library in order to use IOStream. In that same sense, we need the CMath library in order to use some of these functions we are speaking about. So this is the CMath. So there are other ones. So if I'm to look at the square root, okay, so SQRT, and let me put in a perfect square over here. So 49. So the square root of 49 is definitely going to be 7, as we have over here. And the square root of 81 is definitely going to be 9 over here. Okay. However, if I do the square, this is not a perfect square, but then it's actually going to calculate it and give me some floating point value as we currently have it over here. So this is the SQRT. And once again, if I don't include the CMath library and I try checking this, it is going to prompt me. All right. So clearly, with the exams, even if you forget and you have an understanding of what you need to do, the moment you see this, it should just click that, oh, okay, there's a library I need to import, and then you bring it up over there. So I'm bringing this up because of the fact that we are using the SQRT, or we are going to use the SQRT over here. So it is going to be the square root of the length squared plus the width squared. Okay, that's an interesting one. So now let's come in here and the diagonal length. So let me have this and let me call this float. Then I'm going to call this diagonal length. Okay, the diagonal length this way. And in here we would want to return. So we would want to return, and let me put this in a bracket so that things don't get, okay, let me do it this way. So SQRT, and inside of this I would want to have, first of all, the power. Okay, then I'm going to do the length squared. So I'm going to have L, which is the length, comma 2. So this is going to be the length squared, plus, then I'm going to have another power method over here. Then this is going to be the width raised to the power 2. So this is exactly what I want to return. All right, so now let's call the diagonal length method over here to actually test this. So I'm going to say plot 1 dot, I want to go into it, and then I want to have access to the diagonal length method over here. So now when I run this, we get this value. Okay, so now let's try and do some manual calculation over here and see if it is actually what we get. So let's do, or let's bring up the calculator over here. Okay, so what is going to be the value? So it is going to be the length squared. Okay, the length, let me just shrink this a little bit over here. Okay, so the length was how do you call it, 10, sorry, the length was 20, so 20 squared. So let's have 20, where is this squared? Okay, so 20 squared is going to be 400. Okay, plus 10 squared. Okay, so we have 500, and now we are finding the square root of 500. So over here, I think which one is this one? Yes, so when we find the square root of 500, we have 22.360, and this has been approximated to 7 over here. So that's exactly what we see over here. So clearly, when we do the manual calculation, everything looks perfect over here. But then once you have some of these things, you test with different examples to actually check if everything is working perfectly. All right, so that basically brings us to the end over here. But then there are lots of things you can really think about, and if you have a little bit of an issue, you can reach out to me through your class reps. You can take my number, and maybe if there are some few clarifications, I can help you with that as well. Now I'm uploading this video on not my YouTube channel per se, but then let me just show you this. Now when you go onto YouTube, let me just show you my official YouTube channel, this one, Cambridge. So I'll actually have a more polished video of some of these things over here, and then I'll put them over here. Now I've been recording this video, and there are some issues that I'm getting in terms of sound quality and also some editing. So I'll quickly fix that, and I'll definitely make them available. But as you have it, there are some videos that already exist over here, and you can check this out. So you can just do a Google search of Cambridge, or you go to YouTube, and then you search Cambridge. Okay, there's a name, Cambridge, and it will get you here. You can subscribe to the channel, look at some few things over here, and then learn. Okay, there are more to learn over here. All right, so thank you very much, and then I wish you all the best in the exams. All right, bye bye.